All right, the last video is defining and using probability. We're going to talk about odds, and we're going to talk about geometric probability specifically in this video. So odds is actually a pretty easy concept, and geometric probability you did in geometry, so this one is probably not going to be too difficult. All right, so what is odds? It's used to measure the chances in favor of an event occurring or the chances against an event occurring, and we'll define that further. Experimental probability is a calculation of a probability of an event based on performing an experiment. So if I didn't know the actual answer, I could do an experiment and see what my chances are. And geometric probability, of course, is the probability found by calculating a ratio between two lengths or areas or volumes, so something dealing with a geometric situation. So let's start with odds. If I want to know your odds in favor of event A, for example, let's say I wanted the odds in favor of getting a female. Okay, so if I took your class of 35 students, and let's say there were 14 females, that means that there's 19 males. So the odds in favor is the number of outcomes in event A. Okay, so let's say I had 14 females. And then your denominator is the number of outcomes not in A. So if I had 14 females, then I don't have 19 females, or I have 19 males. It is not probability, okay? Odds is not probability. So you do not divide this out and give me a decimal, because it's not your chance of something occurring. It's the odds in favor of getting a female. So 14 to 19 would be that odds. Now, odds against an event would be just this flipped. So number of outcomes not in A. So if I wanted to do the odds against getting a female, then I would find all my non-females, so I have 19 males, over the number of outcomes in A, which would be being female. So it's just reciprocal of that. So it's pretty simple. Okay, an example here says a marble is drawn from a bag containing 6 red, 12 yellow, and 9 black. Find the odds in favor of drawing a red marble. Okay, so odds in favor of red. Well, I have 6 red, and I have how many non-red? 12 plus 9, so that's 21. And when you can reduce odds, you should. Remember, don't change this to a decimal. Write yourself a huge note. Odds is not probability. You don't divide this out. So odds in favor of red would be 6 red. For how many not red? Well, 12 plus 9 is 21. And then I can divide both of those by 3 to get 2 to 7. So I have a 2 to 7 odds of getting red. Okay, then part B asks you for the odds against drawing black. So I don't want black first, right? Because it's odds against black. So how many not black? Well, I have 9 black, so that means I have 6 plus 12, so 18 not black. Against how many blacks do I have, which is 9, and that reduces to 2 to 1. So I have 2 to 1 odds of not getting black, or against black. All right, experimental probability is when you actually do an experiment, and it consists of a certain number of trials, and the experimental probability is the number of trials where you get what you want divided by the total. So if I were going to sit and roll a die 15 times, what is the experimental probability of rolling a 6? That means I literally have to pick up a die and roll it 15 times and count how many 6s I get. And then, of course, I'd write that as an answer. So how many 6s do I get out of the 15 times I roll? And then whatever that may be is my experimental probability. Now, the theoretical probability of this is the actual answer. So what is the probability that you will roll a 6? And you know that that's 1/6 chance. So when I do the experimental probability, it's not likely that I'm going to get exactly 1 out of 6 times that I roll a 6, but it could happen. You just never know. So here's an example of experimental probability. It says exam grades of students in a history class are shown. Find the chosen probability that a random student in this history class received a C or better. Okay, so a C or better, of course, is it A, B, or a C? So that's all of these students. So I know that that probability is going to be 8 plus 12 plus 7. Out of all of the students, well, all of the students are A, B, C, and the D and the F students. So 8 plus 12 plus 7 is 27. And then plus 4 more is 31. And then you can type that on your calculator. And 27 divided by 31 is 0.871. 0.871. So it's very likely that you will get, and you can tell by the graph. So again, C or better, that's all of these students divided by the total number of students. So experimental probability is pretty easy. Okay, you try these now that you kind of understand how the problems work, and then, so pause the video and try it, and then unpause and see if you get the answers. All right, so the first one was finding the odds in favor of drawing a yellow marble. So I want all the yellow versus all the not yellow. So I had 6 yellow, and then I have 6 plus 9, which is 15, plus 11, which is 26 not yellow. Divide both those by 2, and my odds are 3 to 13. And the second one, find the experimental probability that the randomly selected student gets a C or lower. So that would be the C, D, and Fs. So 8 plus 3 plus 1 over all of the students. So 8 plus 3 plus 1 plus 12 plus 7. And so that would be 12 out of 31. And as a decimal, that is 0.3871. Okay, last one is geometric probability. So find the probability that a point selected at random comes from the shaded region. So my shaded region is like this pink region here. Okay, not this. So I don't want that circle. So I want the probability of getting the shaded. Well, the shaded region is not a shape. Like I can't just figure out the area of this and this, but I can figure out the area of the rectangle, subtract out the circle, and that's going to leave me with my shaded. So I want to do the area of the rectangle minus the area of the circle, and probability is always out of the all the possibilities. Well, in this case, all possibilities is the area of the rectangle because that encompasses everything. So area of a rectangle, you should know, is length times width, right? So 28 times 12 minus area of a circle, which is pi times radius squared. And the radius of this circle, if this is 12, the radius is 6. And if you can't see that, stop and take a look. So the radius is 6, right? Because half of this is, half of 12 is 6. So pi times radius squared, and then I'm going to divide by the area of the whole thing, which again is the rectangle. Now take a second and dump that into your calculator. And I'll simplify this a little bit more. So I get 336 minus 36 pi divided by 336. And when I take 336 minus 35 pi, and or 36 pi, excuse me, that's approximately 222.9 divided by 336. And when I divide that out, I get 0.6634. So it's pretty likely that I'm going to hit that shaded region, which probably makes sense. So again, if I go up to this picture, I wanted the shaded region, so I took the area of the whole, take away the circle, and then divided by the area of the whole. So it's not too bad of a problem. And you won't have to know anything more than like area of a rectangle, square, maybe a triangle, 1/2 base times height, or a circle, and that's about it.